Good afternoon. Welcome to Chapter 6. For Chapter 6, you are going to need your journals to be torn out from pages 163 all the way up to 184. This chapter will only have lessons 6.1 through 6.4. So pause the video and tear out pages 163, 163 to pages 184. Once you are ready, proceed with the video. Now, our first lesson is lesson 6.1, and it starts on page 164. So let's get ready. Let's set up our lesson before we begin. On page 164, please place a blank half sheet of paper right across page 164 like this. On the next page, on page 165, do the same thing. Place a blank piece of paper, a half sheet preferably, over page 165. Pause the video and start it back when you are ready. On the next page, page 166, please write down the following problems in the following location. 1A, 1B, and problem 2 on page 166. Once you're done, turn it over to page 167, and we're going to do problems number 3 and problems number 4. Before we start with any of the theorems, let's start with a few constructions. So please go back to page 164. Now, the first construction that we are going to do on page 164 is the perpendicular bisector of a segment. Okay, perpendicular bisector of a segment. So the first thing that you are going to need is obviously a segment. So down here at the bottom, please create a segment. The size of it doesn't really matter. Just maybe make it about, 3.5, 4 inches or so. So here is your segment. Now I am going to mark these endpoints A and B. So what my goal is here is to create a segment that is going to be perpendicular to AB and that it cuts this segment into two congruent parts and it's going to be at its midpoint. So for this, you are going to need your compass and your protractor. So let's start off first with our compass. And yes, you do have to know how to do these constructions that I'm about to show you. So first thing you got to do is make sure you open up your compass to a distance that is more than halfway, and estimated more than halfway, of the length of this segment. Like for example, this length will be too small. This length will be probably too small. You probably want to do it maybe like 3/4 of the size. Not necessarily the distance of the segment. So what you're going to do is you are going to create 2 arcs from each endpoint. So remember, move the paper, not the compass. So make sure you're on a surface where you can rotate the paper. Okay. So put your weight on the endpoint, lean your pencil forward, and then simply turn the paper as shown. Repeat the process for the other endpoint. So keeping the same distance, put it on A, and make your arc such that the 2 intersections appear. Once you do that, draw a line through those 2 intersections, as shown. Now, what we just did is we just created a perpendicular bisector, and it's going to go through the midpoint. So therefore, segment AM is going to be congruent to segment BM. Okay, so what did we just do? We just created this line that we're going to call line L. Okay, we just created this line L. Let me fix my lighting. It seems to be a little too bright. I think that's better. Or off. Is that better? Off is better. Okay, so that is line L. So what we just created is we just created line L perpendicular to segment AB. Okay, at point M. Okay, now therefore you now have two angles. You have this angle here and this angle here, which is of course also another right angle. Now I'm going to place a point somewhere on this line that I am going to call this point X. Okay, so in here what you have is you have both angles AMX and angle BMX. They are both right angles. Okay, they're both right angles. Now, what I want to do now is I want to create a set of triangles, and we're going to do that in this next step. So the triangles are going to come from points X and A. So I want you to construct a line segment from A to X and from B to X. Okay, so what you see here is two sets of triangles. So one of the things I want you guys to notice is that we already have these two segments congruent. We already have this set of angles right here congruent. And now what we're going to do is we are going to look at segment MX. So here, segment MX is congruent to segment MX. And why is that? Well, if you recall, this is the reflexive property of congruence. Okay, it's the reflexive property of congruence. So what is that going to tell me? Well, it's going to tell me the following. Okay, you have side angle side, side angle side, and therefore the two triangles are going to be congruent. So you have triangle AMX congruent to triangle BMX by side angle side. Therefore, now you have a pair of segments that are congruent by CPCTC, which in this case, its segment AX is going to be congruent to BX. Okay, so those two segments are going to be congruent. So what does this mean? One of the things that you have to realize is that X is on the perpendicular bisector. Okay, the location of X is that X is on the perpendicular bisector. So what does this mean? This means that any point that is on the perpendicular bisector is going to be equidistant to the two endpoints, which is what my conjecture is going to be. Okay, the distance from a point on the perpendicular bisector is equidistant to the endpoints. Okay, so let me see if I have enough space to write that down. Okay, so the distance, the distance from a point on the perpendicular bisector, on the perpendicular bisector is equidistant. Means the same distance. Equidistant to the endpoints. Well, what does that mean? That means that if I have a point, say right there, the distance from that point to A is the same as the distance from point B. If I have another point right there, the distance from that point to A is the same as the distance from this point to B. And that is going to be our first conjecture, which will lead into a theorem. Okay, so once again, this is the perpendicular bisector of a segment. Okay, our next construction is going to be about the angle bisector of an angle. So for that, turn to page 165 and construct yourself an angle. So what we are going to be doing is we are going to be doing the angle bisector to an angle. Now we have done this construction before. Okay, we have done this construction before. We just didn't do much with it. So first thing you need is obviously an angle. Give yourself a good size angle. Okay, here's one. Something like this. Okay, and I'm going to call this right here vertice A. Okay, so what we're going to do is we're going to create an angle bisector. Now, in order to do this, I suggest you turn the paper such that the angle is facing away from you, kind of like a V. Okay, open up your compass to any distance. Make sure the distance is less than this though. Okay, and simply create an arc intersecting the angle, like this. Keeping the same distance, put your metal piece on the first intersection and create a small arc in between. And repeat the process for the second intersection. Do that until you have an intersection in the middle. You do it from this point and from this point. You can keep the same distance that you had from here to here. It doesn't matter. Okay, once you do that, what I need you to do is grab your protractor, line up the angle A, the vertex A, with that intersection, like this, and simply draw a line across, like that. So what did we just do? We just created an angle bisector. So this angle here is congruent to this angle right there. Okay. Now, here comes the next part that is a little bit challenging. Okay. What I want you to do is I want you to pick a point somewhere on this line right there. It doesn't have to be this point. It could be really any point. So I'm going to pick a point, I don't know, say right there. I'm going to call this vertice D. Now, what I'm going to do is I'm going to create a perpendicular from that point to a line. Now, we have done this construction before. So if you don't recall that construction, pay a lot of attention and replay this part as many times as you need to. So it's very simple. Okay, you're going to turn the paper such that the point is above the line, kind of like this. I don't know if you can see it. Okay, the point is below the line. So open up your compass such that that distance is past the line. You can see here it's too short. So you have to open it up just a bit. Sometimes you might have to extend your line, which is what I believe I'm going to have to do. From here, create an arc, hitting the line twice. You notice that my line is too short. So very easy fix. All I have to do is extend it. Like this. Okay. I don't know if you can see it. Okay, a little better. Okay, so now that you have that, here's what I want you to do. From these two intersections, create an arc above here such that when you have an intersection, you're going to connect that point with that line, with that intersection. So for example, from here, from there, and from there. Well, what's that going to do? Well, that's going to allow me to connect this point of intersection with this. And what that's going to do is that it's going to give me a right angle. Okay, now I'm going to repeat the process for this point to that line. Okay, so pay attention if you didn't get a chance to see how I did the first one. Okay, so from D, I got to go above the line, like this. It doesn't have to cross this arc, by the way. Then from here, and from there. So what that's going to do is I can join this point with that point. And what that's going to allow me to have is, again, another right angle. So now I want you to turn it forward like this. And I want you to see something. Okay, you have 1, 2 pairs of angles. And you have the segment AD congruent to itself. Okay, so this side is going to be congruent to itself. So what do you actually have? You have angle, angle, side. Angle, angle, side. So what does this mean? This means that these two triangles are indeed going to be congruent. So you have triangle. Okay, I didn't give these a letter, so let me give these a letter. I'm going to call this one angle C. Okay, and not angle C, but vertice C, and I'm going to call this one here B. So you have triangle ACD congruent to triangle. You got ACD, ABD. They're going to be congruent. Why? Because of angle, angle, side. So what is that going to imply? By CPCTC, DB is going to be congruent to DC. Okay, so what does this actually tell me? It tells me that any point that is on the angle bisector, okay, is going to be equidistant to the angle, not the line, how do we call it? You would call it to the side that makes up the angle. Okay, so this right here and this right here, they are congruent. Okay, by CPCTC, and we're going to look at the theorems that actually make this up. Now, what do you need to learn? You need to learn how to come up with these constructions and how to apply the theorems. Applying the theorems is actually way easier than doing the constructions. Okay, next page, page 166. Let's go over some of these theorems that we just talked about. All right, the first one is Theorem 6.1, the perpendicular bisector theorem, that states that in a plane, let me see if I can zoom in a little bit. Okay, in a plane, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. In other words, if CP is a perpendicular bisector, then CA is congruent to CB. And it's something that you can easily prove. The converse of that is like this. If a point is equidistant to the endpoints, then this point will lie on the perpendicular bisector of that segment. Okay, so if DA is equal to DB, then point D lies on the perpendicular bisector of AB. Okay, so we're going to be referencing to these two theorems in our examples. The next page, the angle bisector theorem. If a point lies on the bisector of an angle, then it is equidistant to the two sides of the angle. So if this point is on the angle bisector, then the distance from D to the side of the angle is the same as this distance to this side of the angle. And it works backwards too with the converse. Okay, if the distance from D to B and the distance from D to C is the same, okay, meaning that, of course, this has to be perpendicular, then D will be on the angle bisector. Okay, so we are done with the exploration. Let's go ahead and move on to the examples. So pause the video at any time and continue it whenever you're ready. Let's look at example number 1. Okay, so for example number 1, it says, find each measure. They want me to find the measure of RS. So the first thing I want to ask myself, is this a perpendicular bisector? So you have to check for 2 things. 1, are the lines perpendicular? And is it intersecting at the midpoint? Okay, looking at this diagram, you can see that this is a right angle. Okay, so therefore, they are perpendicular. Okay, is the other one at the midpoint? Well, how do you check? You check to see if these two are marked congruent, and you can see that they are. So yes, it is at the midpoint. Therefore, S right here is going to be equidistant to both of these sides. So here in this problem, RS is congruent to PS. Therefore, their measurements are equal. So what is the length of PS? 6.8. So what does this mean? This means that RS is 6.8. That's simple. Could you do this part visually and not have to write it down? Of course. But it's always good to check. Okay, now on this one right here, okay, they're asking me to find EG. So my question is, well, what do we have? We have HG and HE congruent. Okay, HE and HG congruent. That means that H is on the perpendicular bisector. Okay, so since this is a perpendicular, that will imply that this line here bisects this whole segment, which means that EF is going to be congruent to GF. And what is the measurement of GF? Well, the measurement of GF happens to be 9.5. So therefore, EF is 9.5. And that's example number 1. Let's look at the next example. Okay, in this next example, it's a little difficult to see the diagram, so I'm going to redraw this. So what you have here is simply a triangle, and you have a line that goes like this. Like that, you have K, L, M, and N. And they want to know, is there enough information in the diagram to conclude that the point N lies on the perpendicular bisector of KM? Looking at this, remember, you have to check for 2 things. 1, is it perpendicular? Okay. 2, is it at the midpoint? It is at the midpoint. Why? Because you can see here that these 2 segments are congruent. Is it perpendicular? Well, there is absolutely nothing here that allows me to state that they are. Just because it looks perpendicular does not mean that it is. So is N on the perpendicular bisector? Unfortunately, in this problem is a no. Okay, N, not N. Okay, N is not on the perpendicular bisector. It's just not. That's example number 2. Let's look at example number 3 now. Okay, so for example number 3, we're going to use the angle bisector theorem and its converse. So here, they want me to find the measure of angle GFJ. Okay, so pretty much what is this angle right here? So one of the things that you have to check here is JG congruent to JH? The theorem says that if, actually the converse, if a point is on the interior of an angle and it's equidistant to the two sides of an angle, then it lies on the angle bisector. And in this case, yes, it does, because these two right here are 7. That means that J is on the angle bisector. So what does that mean? That means that this line cuts the whole segment, the whole angle, in half. So if this is 42, so is this. So the measure of angle GFJ is equal to 42 degrees. And that's it. RS. One of the things that you can see here, if you look closely at this part right here, you notice these two angles are congruent. And S happens to be on that line, on this one, the one that splits this angle in half, that it's an angle bisector. Therefore, okay, if you notice here, these are perpendicular. If these are not perpendicular, then you can't assume that those two triangles are congruent. But here, it is a perpendicular. So this is on the angle bisector. The distance from here to the side is the closest. Therefore, these two are actually going to equal. So 5x equals 6x minus 5, and you simply solve for x. You get negative x equals negative 5, and when you divide both sides by negative 1, x is equal to 5. Okay, but that's not the answer. What you have to do is you have to go back and plug it into RS. Okay, now RS and PS is the same thing. I could really put them in on both. Okay, but I'm going to do it in RS. So RS equals 6x minus 5, which means that I'm going to substitute that value in there. 6 times 5 minus 5, that's going to give me 30 minus 5, which is 25. So RS is equal to 25. Okay, let's take a look at the last one. Apparently my lighting has been terrible today. Let me see if I can get a little better. See, sometimes it's too bright, sometimes it's not bright enough. Okay, I think this works. All right, so that is example 3. Let's look at the next example. It says a soccer goalie's position relative to the ball and the goalpost forms a congruent angle as shown. Okay. Will the goalie have to move farther to block a shot to the right or to the left? So let me redraw what's going on here. Okay. You have point B, and you have a segment right here, L and R. Okay. And what it's telling you here is that you have the goalie somewhere around, here. Okay. So this angle here and this angle here, they're congruent. They tell you that they're congruent. I know it's kind of hard to see it in there, but they are. So this point right there, they want to know if he has to block the shot, will he have to move further to the left or to the right? Well, the goalie is on the angle bisector, so even if he has to move, to the left or to the right, he's actually equidistant to both of the two sides. Okay, so what would you have to put? Well, you can say that the distance is the same. Okay, you can just say that the distance is the same. He doesn't need to move further to the left or to the right because he's pretty much in a good spot. He can go to the left or to the right, depending on where the player is going to throw the ball at. Okay, if he plays for Chivas, he's probably going to not make it anyway. So I don't know what I'm saying. Anyways, so that is example number 4. Okay, so please make sure that you guys have your full set of notes, and I will see you all later.